Okay, so in this video, let's talk about inverse derivatives. So before we talk about the derivatives, let's talk about what an inverse actually is. So one thing you must understand with inverse is that the x and y switch. So for example, let's give ourselves a simple function. F of x is equal to x squared. Actually, I'm gonna increase. Okay, f of x is equal to 2x, right? So if we create a table, right, where we have our inputs and then our outputs, x and y's, and we plug in three simple points, right? One, two, three. If we plug these numbers into our function, we'll get the following outputs, right? So we get 2, 4, and 6. However, with our inverse, right, we're gonna switch our x and y. And here, let's actually see this. So if we have f of x is equal to 2y, right? So we want to switch, to find the inverse, we want to switch our variables. So we have x is equal to 2y, and we want to isolate y. So we're going to divide both sides by 2. And then we're left with y is equal to, or is equal to x over 2. However, we want to distinguish this y with this y. So we're simply going to change the notation as f of inverse of x is equal to x squared. And now let's create a table. So, right, our x and y's are changing. So, x and y. So, what was previously our output, what was previously our y value, is now going to be our x. So, we have 2, 4, 6. And what was previously our input is now going to be our output. And this does make sense because if we plug in 2 into this function, we get 1. If we plug in 4, we get 2. Plug in 6, we get 3. And this shows us that whatever we're plugging in, right, whatever's it, our input, and we find the inverse is now going to be our output. And what was previously our output is now going to be our input. Okay, let's also see it this way. So we have f of x is equal to y, right? And we want to find the inverse. So we're gonna first switch our variables. So we have y is equal to x, or sorry, um, f of y is going to be equal to x. And now we want to find the inverse. So we do the inverse of f of y is going to be equal to f inverse of x. Right, and this will just cancel, so we're left with y is equal to f inverse of x. And this shows us, right, our inputs are now our outputs with the inverse, and our outputs are now our inputs. And right, and now as we move on to the derivative portion, right, when we find the over dx, the derivative of an inverse, this can simply be rewritten as 1 over f prime of f inverse of x. However, when I first learned about inverse derivatives, I hated doing problems like this because this was very confusing. Because it made you think it made you think going backwards. So what you would normally do, now do it backwards. However, it can be much simpler and much easier to do once you realize this. 1 over f prime of y. And now seeing this is basically telling you find a derivative of your function, set it over or set it under 1, and then you can plug in your output into that function, right? Because your output is your y, into the derivative, and that gives you your answer. Okay, let's do it with this, right? So as we were given the problem, right, f of x is equal to 2x, right? Well, first we want to change our variables. So we have x is equal to 2y. And now we want to separate y. We want to isolate y. So we're going to divide both sides by y. By 2, sorry. And this is going to be equal to y is equal to x over 2. However, again, I want to change the notation just so it's easier to distinguish which is the inverse and which one is the original function. So I'm going to do f inverse of x is going to be equal to x over 2. And now we can find a derivative of this, right? Because, right, is going to be equal to f or f prime of x. Oh, or let's rewrite this whole thing just so it makes a lot more sense. So we do f inverse of x is prime, right? Find the derivative of that is going to be equal to x over 2 prime with f inverse of x prime is simply 1 over 2. Right, because if you find the derivative of x over 2, it's just going to be the derivative of x is just 1, so then you're left with 1 over 2. And we can prove this with another method. So, right, if we have f of x is equal to 2x, we can find the derivative right away. So we have f prime of x is equal to 2. And we can set this under 1 because as we remember, right, uh, our derivative of the inverse is simply 1 over f prime of f inverse of x, right? So we plug this into this form, right? So we have 1 over 2. And because there's no other variable, there's not x, nor there's a y, right? We don't need to go a step further. But if we did, we would have to find the inverse of y and then plug that in. But since we have no other variable, this is simply our answer. And we can see this checks out. All right, let's do another problem. All right, so let's say we're given f of x is equal to x squared. So one of the methods we can do is start off by finding the derivative. F prime of x is simply 2x. And now we want to switch the variable. So this is going to be x is equal to 2y. So then we can put this as 1 over 2y, right? Because as right, we remember 1 over f prime of f inverse of x is equal to the derivative of the inverse. However, you may be quick to assume that this y represents x squared. So you may do this. However, this is incorrect. Because remember, this y, as you remember at the beginning of the video, this y now represents f inverse of x. So it is no longer your f of x is equal to y, right? It's not that. But we're finding the inverse. So now we take this original function, right, and we switch variables and solve for the inverse. So we have y is equal to x squared. Switch them so we get x. X is equal to y squared. Square root to cancel the exponent, square root, so then we're left with y is equal to x squared, or the square root of x. Right? And now we do have the inverse. So now we can just go right away, right? So we said this was wrong, right? Because that doesn't take into consideration of the inverse, rather just the original. So now we can set this equal to 1 over 2 of square root of x. And that's correct. And let's do another method. So if we have, right, we still have f of x is equal to x squared. We can start right away by finding the inverse. So we want to switch the variables is equal to y squared. The square root to cancel the exponent, and we're left with y is equal to x squared. However, let's change the notation once again, just so it could be easier for us to distinguish, right? F inverse of x is going to be equal to square root of x. And then we can find the derivative of this, right? We can just derivative. So first, to find a derivative, we have to change the notation of the square root. So we know that the square root of x is equal to x 1 over 2. And if we apply power rule, it's going to be 1 over 2. And then we're going to subtract the exponent by 1, which is going to leave us with x to the power of negative 2. And this is 1 over 2 square root of x. And we can see it checks out. We get the same solution with both methods. And there's other methods you could also use, and I suggest you use the method that works better for you. These methods, you're not limited to just doing these methods, but rather you can go online and investigate other methods you could use. Different teachers apply different methods and can be easier for you. And I suggest that you do the method that's easier and faster for you, especially for exams, right? You want to solve a problem as fast as possible. All right, let's do another example. So if we have f of x is equal to x cubed minus 1, right? So one of the first methods we can do is right away find the derivative. And applying power rule, we bring down the exponent and then subtract the exponent by 1, which is that. And then the derivative of 1 is just going to be 0, so we don't have to take that into consideration. Now we want to switch the variables. So now this is going to be x equals 3y squared. Remember, we have to write this under 1. So this is going to be 1 over 3y squared. So now, right, remember this y represents the inverse of this function. So we can't just plug this in. Now we can find the inverse. So we're going to set y is equal to x cubed minus 1. Switch the variables. We have this, right? Now we're going to add 1 to each side. Each side we're going to add 1. That will just cancel. Plus 1. We get x plus 1 is equal to y cubed. And we want the cube root to cancel the exponent. And we do the same to both sides. So we get y is equal to the cube root of x plus 1. However, I want to change the notation. So it's going to be f inverse of x is going to be equal to the cube root of x plus 1. Now we can plug this in. Is equal to 1 over 3 cube root of x plus 1 squared. And that's our answer. And let's do the other method. So with the other method, we're just going to right away find the inverse. So we have y is equal to x cubed minus 1. Switch the variables. Y cubed minus 1. Add 1 to both sides. X plus 1. This one will just cancel. We're left with y cubed. Do the cube root to cancel the exponent. And then we'll do the cube root to both sides, right? So with y. Now, again, let's switch the notation just so it's easier. And I highly suggest you get into the habit of switching the notation just because, like, when you're taking an exam or you're doing practice problems and you may be limited on time, you can easily confuse yourself with this y as being your original function. So it's much easier to just right away switch the notation. So you're like, okay, this, I understand this represents the inverse. So I have to use my inverse and not my original. It's also like it can be a simple mistake that you can compare this mistake to a simple mistake as like mistaking your plus or minuses. It can be avoided if you just organize all your work neatly. So, right, we're left with x plus 1. And now we have to find the derivative of this. So we find the derivative of this and the derivative of this. However, this will require you to use chain rule. So let's write down this here. So x plus 1. And we're doing the derivative. So we're going to do prime. So let's start with what's our inside. So what's in our inside will be labeled as a of x is equal to x plus 1. Because that's what we're putting inside, right? However, what's outside is the cube root of x. And we want to find the derivative of each function. So a prime of x is just 1. B prime of x is just, we got to change the notation first. So this can be represented as 1 over 3. So when we bring down the exponent and then subtract 1 to the exponent, we're left with 2 over 3. And this can be written as 1 over 3 cube root of x squared. Okay, so now that we have this, we know what's our inside and outside and the derivatives to each respectively, we can apply chain rule. So we're going to do the outside, right? Our outside, right, is the cube root, and we want to do the derivative of that. So we're going to do 1 over 3 times the cube root, and then we're going to plug in what's the inside of the function. So x plus 1 squared. And then we're going to multiply this by the derivative of the inside, which is just 1. So we don't really need to include this because anything times 1 is just itself. So this is our answer. And we can see this answer choice matches up with what we got here. Okay, let's do one last example. But with this example, I want you to get familiar with your derivatives of your inverse trigonometric functions. So with our trigonometric functions, right, we have cosine, sine, tangent, secant, cosecant, and then cotangent. However, we're dealing with the inverse, so we're gonna understand it by just inverse. Right, we're gonna do that to everything, and now we want to find a derivative. However, you could prove this. However, if you're taking a course like AP Calculus, AB or BC, you don't need to prove it. You just need to memorize it, and that follows through with even other college courses and most classes. However, if you need to prove it, that's would be in another video, and we're not going to get into that. So if we do the derivative of each inverse trigonometric function, right, you would have to memorize this. However, it's really simple to memorize it once you understand the organization that it follows. So as your normal uh, derivative inverses, or sorry, your derivatives of your trigonometric functions, all the trigonometric functions that start with the c will be negative. So we can just already start these off with negative. Will be equal to some value that is negative. Okay. And then with cosine, it's just going to be 1 over square root of 1 minus x squared. And then sine, which is going to be 1 over square root of 1 minus x squared. And you can see these are the same thing. However, the only difference is that because this starts with the c, it will be negative. And with tangent, it's just 1 over x squared plus 1. Now, with tangent and cotangent, these are the only ones where you'll see x squared and 1 being added to each other. Like, these are the only ones where they're adding, right? So, with cotangent, right, it's just going to be 1 x squared plus 1. It's literally the same thing, but just a negative. And with your secant and cosecant, it can be a bit different. However, the way I understand or distinguish your secant and cosecant from your cosine and sine is that your secant and cosecant, they want to be close to the other x. And here you'll understand it. So we have the absolute value of x, this times the square root of x squared minus 1. So when we look at cosine and we look at secant, we can see that in secant, right, this x is all the way to the left. And the way I memorize it and understand it is that your x with your secant and cosecant want to be buddies. They want to be friends. So this x is good. The x inside the square root will be all the way to the left side because it wants to be next to its other x. And again, the cosecant and secant are going to be the same thing. However, the only difference is the negative. So just 1 over x squared times, or 1 over the absolute value of x times uh, the square root of x squared minus 1. Right? While with cosine and sine, the x wants to be all the way to the left side. They're not like secant and cosecant where they want to be buddies. Okay. Now that we understand this, I suggest you to memorize this. There's a bunch of flashcards you can use in Quizlet, and just memorize these, especially for the exam or for any quiz you have coming up that deal with inverse of trigonometric functions. Now let's do an example. So we have f of x is equal to cosine of x, right? And then we'll apply both methods that we previously used. So first we want to separate, or we want to identify the verb. So we have y is equal to cosine of x, and then let's switch variables. So we have x is equal to cosine of y. And the only way we can isolate y is by doing the inverse of cosine, or it's also commonly referred to as arc cosine. So we're going to do cosine of inverse of cosine of y, and this is going to be equal to, this is an x, by the way, x of cosine and inverse of x. Now these cosines will just cancel, leaving you with y is equal to inverse cosine of x. Again, let's change the notation. So f inverse of x is equal to cosine of x. Now, from here, we can simply apply the derivative. We can find the derivative. And again, as we've seen here, we're just doing the same thing. We're just going to find the derivative by just simply memorizing it, right? So we have f inverse of x prime is going to be equal to 1 over the square root of 1 minus x squared. And that's your answer, right? Okay, and then if we go and do the other method, right? So we have f of x is equal to cosine of x. The main difference between these methods is that here we see that right away we're solving for the inverse. Well, with this other method, we're finding the derivative right away. So we have f prime of x is going to be equal to negative sine of x, right? Because cosine starts with a c, it's going to be negative. And then now we're going to switch our variables. So there's going to be x is equal to negative sine of y. And as we recall, f prime of f inverse of x is also equal to f prime of y. So we're just going to substitute that in as is equal to 1 over negative sine of y. However, remember, don't mistake this y with your original. It's your inverse. So this is simply going to be f of x is equal to cosine of x. Switch the variables, so it's going to be x is equal to cosine of y. Isolate, right? So we're going to do arc cosine. So we're going to have cosine of inverse cosine of x. And then remember the inverse cosine with this cosine will just cancel, leaving you with y. So we can change the notation as f inverse of x is equal to cosine of x. And then we can now substitute this into this, right? So we have 1 over negative sine of cosine of inverse of x. Now, although they look very differently, right? This and this look different. If we plug this into a graphing calculator, they equal the same thing. And for the sake of this, here, let's plug this into Desmos. Now, here we see that we get the exact same graph for both, right? So here, right, we can see that they overlap. And that goes on infinitely, right? because they're the exact same thing. Although they look very differently, right? The methods used as explained still apply, and they apply to whatever function you can use. And yeah, another big thing you should note from inverse derivatives is that inverses is very different from your reciprocal. And the last thing I want you to take away from this video is that with your reciprocal, right, f of x, with reciprocal is just 1 over f of x. This is your reciprocal, right? This is reciprocal. Well, when you're specifically talking about your inverse, you're referring to switching your x and y values. So whatever were your x values previously are now your y values. So whatever is your input will now be your output. And what was originally your y values are now your x values. So what was originally your output is now your input.